what she did for 5 minutes.
All right.
Yeah, and she's made me deliver paper to the council.
So we saw yesterday, we were kind of touching on it at the end, but then I gave you that paper with the graph, so hopefully you're recognizing. We only have an overall limit if the limit from the left and right match up. They have to go to the same number. So we can have a one-sided limit, a limit from the left, we can have a limit from the right, but we only have the overall two-sided limit if those two match up. When we're looking at our graph, that means if there's like a break in our graph, the limit isn't going to exist there. But if there's an open circle, does that matter? No, because limits don't care what happens at the point, just as we are getting close to the point. So let's try, I jumped around a little bit yesterday. Did we do this one? No. Okay. But I didn't skip any other examples before this, did I? No. Okay. So if I were going to draw a graph, that might help me here. You have to remember your piecewise graphing skills, which came in handy on your homework. When you're looking at that, the first piece is 1 if x does not equal 0. Now, if you were going to make a t-chart, usually when we graph piecewise, we did a t-chart for everything, you still have to plug in 0. And what would I get out? Nothing. Well, we get 1, but what kind of circle do we mark that? That's an open. And then any other x value I might put out, we're still getting 1. So if we think about this, 0, 1 would be open. I put 2, 1 and negative 2, 1, but you could do different points. What kind of line is this? All lines are linear. Horizontal line with the hole in the middle. All right, and then how do I graph 0 if x equals 0?
Dot at 0.
Yep, a dot at 0, 0.
Oh, yeah.
Okay. So, do we have the limit as x approaches 0 of this function?
Does it matter at the point?
No, because if they don't match up.
They don't? So as I'm coming in from the left, it's going to
0.
no, 1. As I'm coming in from the right, it's going to 1. So the overall limit is?
I forgot f of x means y.
Oh, yeah, f of x is sharp y. Now, is that the point on the graph?
No.
No, the true point is 0, 0, but remember, limit doesn't care what happens at the point, just as we approach the point. We get 1 for our limit. All right, all of the limits we've done so far, we've either gotten a number answer or do not exist. But it is possible for a limit to equal positive infinity or negative infinity. Because if you think about,
That's just really funny. What?
think about cases like asymptotes. We know a vertical asymptote, you're getting closer and closer to it, but not approaching it. So if, I think I put some graphs on here.
Yep.
Okay, so if I look at this, I have a vertical asymptote as A. At A, as I'm approaching A, this side, the y value is going to infinity, this side is going to infinity, so our overall limit would be infinity. Same thing could be if they're going down. If both ends are going down approaching that asymptote, my limit is going to negative infinity.
Oh, so what the A is?
A is just, yeah, that pink. I'm just showing you a visual.
It wasn't dotted, so I was
I
also
know.
kind of
I
confused.
took the picture out of your textbook and made it
How
dotted.
dare they?
I know.
So is this like kind of like that, what's like the interval, like?
When the interval rotation
As
was,
x is going towards 1, y
Mhm.
is
Yep.
going towards.
when we talked about end behavior and I
Oh,
gave you the
end behavior.
formal definition of it, yes, that's exactly what this is.
It's like end behavior.
This one, we can see we can have infinity for one-sided limits too. As I approach A from the negative, this is going to positive infinity, so forth. So it can have a one-sided limit or a two-sided limit. Okay, all these, infinity is an option. So let's try a couple.
You think pass?
I didn't. I wanted to. draw a graph. We know what the square root graph looks like, don't we?
Sure.
Let's draw it. Can I put in negatives? Can we do the square root of a negative?
No.
Okay, square root of 0 is
0.
square root of 1.
1.
Square root of 4.
2.
So this graph is like this. Okay, so the limit as we approach 0 from the right. So as you are coming in from the right, approaching 0, what's our y value going to? 0. Limit as we approach 0 from the left.
None.
There isn't anything from the left. So what do you think our limit would be?
No
Yeah.
solution.
Yeah.
Whatever.
Does not exist.
Yeah.
D
Yeah.
does not exist. Okay. Let's try another one. Do we know what the graph of this looks like automatically?
No.
So how would I figure it out?
XY t-shirt. I've given up on not doing an XY t-shirt.
So one of them we need to approach from the right. What does that mean?
Coming from big numbers.
Bigger
Smaller
than
numbers.
3. So like 3.1, 3.01, 3.001.
Oh, I should get
So that would be the t-chart for this one. And then the other one we approach from the left. So what kind of numbers would I put in?
2.9. 2.99.
Okay.
We're taking our respective numbers.
So what I want you to do, you guys plug these in. So the first one, the limit as we approach 3 from the right is,
Negative
Infinity.
from the right is the bigger than 3's.
Oh.
You wait.
And then as we approach 3 from the left,
Negative infinity.
we get negative. Now what if I just said the limit as we approach 3?
No.
No.
It does not
Does
exist.
not exist because the left and right are going 2 different directions. Okay.
Wait, what was that? Oh, of just like.
Yes, if I didn't say left or right.
Yeah, let's go.
So if I don't give you the left or right, you have to do both tables and make sure they match.
I accidentally somehow messed up my one that I did 2 days ago for that homework, and I got one that just was increasing like this. I accidentally made.
Accidentally.
Yeah, I did it wrong.
All right. The limit as we approach 0 from the right. So if you were making your table, do I have to have 2 tables here?
No, you just need the bigger one.
I just need the bigger one because it's only from one direction.
Approaching 0.
It's going from small to big.
So we're gonna have negatives. No.
No,
Right?
We're gonna have higher numbers then.
Oh, we're coming from this way. You're right. You're right.
We're putting things bigger than 0.
Ow.
Oh yeah, we are.
And so I got
Oh, that's interesting number.
So what do you think this is going to?
4.
All right. Do we need more practice with this? Do we feel like we understand our concepts?
How did you get a 9? Did I put my thing in wrong?
So fun.
Is it supposed to be positive?
Yeah, I get a 3.
Positive is going in. What's the positive is going in?
Oh, it's just the x to the 3. It's not 3.
Oh.
All right.
These are silly.
So here's what we're going to do.
Oh.
We're going to stop here today. You have a book assignment at the end of this, right?
What is
Whoa, book assignment.
I
is
saw
so
you.
great.
You gave us our own books. Our books
So
are
we
neat.
are finally using our textbooks.
Finally.
Game plan. So for next week, normally I do a work day over this section. I am actually going to flip a couple things because I know a lot of you are gone Wednesday. So
Oh, yeah.
this assignment I will actually collect until I guess Thursday. I'm gonna kind of alter that. So we don't have school Monday. Tuesday I'm going to begin section 2.3. We will not get all the way through it, but I'm going to begin it. But then Wednesday is going to be a work day for those of you that are here. So if you don't have this assignment done, you can work on it in class. If you're not here, then you just have to have this assignment done when you get back. Does that make sense to everyone?
Who's not gonna be in here? Is it just gonna be me and Grayson?
And submit.
There's
Yeah,
a lot of
Samantha.
you on my roster
She's
that
good.
were gone.
Are you going on a field trip? Okay.
Right, that's what I was saying.
Yeah, there's like 4 of you gone.
No, me and Grayson and you are the only people